Hi, I'm Phyllis Lang and welcome to Nightwear. This video demonstrates creating local horizon models in Deep Sky Planner. A local horizon model is essentially a map of obstructions around your observing location, like trees and buildings. Both upper and lower obstructions can be defined in a model. Not all users will need a local horizon model, and very few will need the upper horizon part of a model. Using a horizon model requires more calculations in Deep Sky Planner, so you should only use a horizon model when needed. The local horizon model is used in two ways in Deep Sky Planner. First, it can be used to filter objects out of a report when the object is obstructed from view. The local horizon filter works like the altitude and azimuth filters that are already present in many of Deep Sky Planner's reports, but it allows you to define a shape other than a flat line. The local horizon model can also be used to compute object rise and set times for the local horizon model rather than the theoretical flat horizon. These uses are demonstrated in another video. Creating a horizon model can be done in three ways. You can enter data points for the model manually. You can read data points from an ASCOM connected telescope, or you can import a model produced by other software. Importing a horizon model is covered in another video. We use the Horizon Model Editor to create a model manually or using a telescope. To access the Horizon Model Editor, click the Location Manager button and edit a location. These are the Horizon Model controls. Click the New button to create a new model in the Horizon Model Editor. And I'll adjust that in the view so that you can see the lower portion of the screen. First, give your model a descriptive name. This name is included with the model if you export it, so make sure it is meaningful to you. Next, we'll develop the horizon model by entering data points manually. We'll develop only a lower model in this example. These are the lower model controls, and these, of course, are the upper model controls. The same process is used in developing the lower model and the upper model. Adjusting the screen once again so that you can see better what I'm doing. Always start with a data point at 0 degrees azimuth, which is due north. Adding an altitude point at 20, and then continuing on with some other data points. 20 degrees azimuth, 20 degrees altitude, 40 degrees azimuth, 30 degrees altitude, 60 degrees azimuth, 30, 80 degrees azimuth, and back down to 20, and then 90 degrees, 15 degrees altitude. Now notice that the horizon model graph changed each time I entered a data point, and that is by design. It helps you understand visually what you are entering in the numerical table. If you enter a point that is incorrect, you can edit it by clicking on the cell in the table of data points and typing a correction. Let's assume instead of 15, I really meant 10 degrees altitude, and I press Enter to save the change. Again, note the change in the horizon model graph. If you enter a point that isn't needed at all, click on the point in the table. And by this, I mean that you should click where the black triangle is. The black triangle indicates that that point is selected. Next, I delete the point by clicking the Delete Selected Point button, and you get a confirmation to make sure that you don't inadvertently delete a point. If you want to delete all the points, you can do so by clicking Delete All Points. Here, I've reopened a horizon model again in the horizon model editor with some data in it. The order of the points shown in this table can be changed. I'll add a point that is out of order to demonstrate. So adding azimuth 45 degrees and altitude 35 degrees, we can see that the point is not in order of azimuth. But we can sort the table by clicking in the header cell, the azimuth header cell, and you can see that all the points are reordered. Data points are sorted automatically for the horizon model graph so that the graph display is always ordered correctly. And the order of these points is also sorted automatically when you save the model. If you have a telescope connected to Deep Sky Planner, you can get altitude and azimuth coordinates from the telescope by clicking the Add Telescope Point button. Notice that it is enabled now because there is a telescope connected to Deep Sky Planner. You can add the data by clicking, and you can see that the data was added at the end of the table. You should follow the procedure as shown previously for manual entry, that is, start at 0 degrees azimuth and work eastwards through south, then through west, and finally to north. Once the model is developed using the telescope, points can be edited and deleted manually, as described previously. When you've finished with your model, click OK to return to the location editor. You can see that the horizon model name has been updated here. Click OK to save the model changes for the location to the database. You should now see the horizon model name in the far right column of the Location Manager list of all locations. That wraps up this demonstration of creating a local horizon model. Thanks for watching.